So far, all of our components have been automatically serialized by the editor. Unfortunately, not all data types are supported automatically. The good news is that you can add your own support by building upon the editor. I've made a simple component which I've called Spatial Component 3D, consisting of a vector 3 called Position. Let's open the editor and try and add a Spatial Component 3D to one of our entities and view it. As you can see, the vector 3 data type is not supported by the editor, and we receive a crashed message letting us know. To allow the editor to support vector 3s, we need to create a UI element, or gadget, to match the data type. Like components and systems, we're going to begin by copying the field panel template file to create a vector 3 panel. This inherits from panel. First, let's look at the constructors. These are required by the engine to dynamically instantiate gadgets. If you just want to use a custom gadget to get components to serialize, you don't need to change these. So long as the existing ones remain, however, you can safely add any extra functionality you like. Now let's look at the default height and width variables. We can afford to be conservative with these because the panel will dynamically resize according to what's inside it. If we had too much, the panel will grow to make room. A default width of about 200 should be good, and for height, let's enter 100. The next step is to start populating our panel. The convention is that a panel is a collection of field gadgets. A field gadget corresponds to a primitive data type, and a field panel corresponds to a complex data type by aggregating a number of field gadgets. Since a vector 3 is actually just made up of 3 float variables, we can use 3 instances of the floatbox field gadget. To add a field gadget, we use the generic addGadget method. All we need to do is specify the type and a label for the gadget, and the engine will take care of the rest of it for us, including formatting. Next is the value property. This is how data is extracted from the field panel. When the editor wants to sync a component according to a panel, it uses this property to determine how the component should be synced. Every field gadget and every field panel must implement this property. Firstly, we change the return type from object to vector 3. Next, we need to create a vector 3 object by combining the values of our 3 float boxes. We do this using the getGadget method, which looks the same as the addGadget method, and then accessing the value property of our float boxes. Finally is the syncGadget method. This is used to update the visual display of a field panel according to a passed-in object. The first step is to verify that the parameter matches the data type we're looking for. If it doesn't, we throw an exception. If it does, then we update the values of our 3 float boxes by calling their syncGadget methods. This process allows us to logically nest gadgets. Now that we've created our vector 3 panel, we need to tell the editor that when it tries to serialize a vector 3, it should use our panel. We do this inside the user setup init method through the GUI event hub static class, which is responsible for the GUI module in the editor. We simply need to associate a data type with a gadget type, and we're done. If we run the program, add a spatial 3D component to an entity and view it, we can see the editor can now serialize vector 3 objects.